All right, to close out this workbook, we've just got a couple of problems on the counting rules. And the first two, just make sure that you know how to compute permutations and combinations. Just compute them. So there are two problems here in problem one. The first is calculate five things 3 at a time as a permutation and 5 things 3 at a time as a combination. So let me show you how to manipulate these, and then let me show you how to use the calculator as well. First of all, by definition, this is 5 factorial divided by what is called the difference factorial, 5 minus 3. So that's 5 factorial all over 2 factorial. And now the way that you just write these out is 5 factorial is 5 times 4 times 3 times 2 times 1, and 2 factorial is 2 times 1. So that 1 divides into the 1 time. Careful with that slash. That slash just means 1 divides into 1 time and makes a factor of 1. Likewise, 2 divides into 2 and leaves a factor of 1. All right? That leaves this fraction as just 5 times 4 times 3 divided by 1, or 60. Okay? Likewise, if I do the same thing over here, this has a different definition now. This is combinations, not permutations. This is 5 factorial all over the difference factorial, like the permutation, but then it's divided by 3 factorial as well. So if I write this all out, this is 5 factorial all over 2 factorial times 3 factorial. Okay, a little different. I've got this factor of 3 factorial down at the bottom. So this is 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 3 times 2 times 1. Okay, so look at that. I've got 1 over 1, 2 over 2, 3 over 3. That's 3 factorial, that's 3 factorial. That all turns into 1. All right, so now I'm left with 5 times 4, 20 divided by 2. I'm left with 10, and there's the 2 answers to this problem. Now, if you just can't stomach that kind of stuff, turn on the calculator. Now we're going to go someplace we haven't gone before. Over on the left-hand corner, if you can see that, all the way over onto the first column, generally there is something called math. We'll hit math. It gives you a large menu. Across the top there's math, noon, complex, prob. Prob is probability. So let's slide over to probability. And now that gives me a whole vertical menu. The second and third choices are NPR and NCR. So let's go down to NPR, select it, and it gives me a little icon that's got a NPR with, instead of, if you do this, you can see there's 2 boxes. The leftmost box is flashing. It's asking you to enter this number, so let's do that, 5. Now let's go across using the toggle switch to be able to enter the next number, that's 3. All right, and now I've got 5P3. Let me enter that, and it says immediately 60. Okay, so if there's questions with that, I'll video this happening, but hopefully you could follow that along. Okay, let's go on to the second problem now. All right, the second problem says we're going to put together a personal identification number with 4 digits. And the question asks, what's the probability that we load up this pen and that there are no repeated digits? All right, so when you're dealing with digits, you're dealing with the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 numbers, and 0 makes 10. That's the 10 digits. And frequently problems like this in probability, they kind of lend themselves to the idea of thinking in terms of slots. I'm going to call this pen 4 digits. I've got 4 slots to fill, so let's think a little bit about that. How many ways can I fill that first slot? Well, there's no restrictions, there's no constraints on that first slot. I can put in any digit that I'd like. And now this second slot, if I'm going to fill it up, fill the pin up in such a way that I have no repeated numbers, then whatever number I used here is no longer on the board, it's out. I only have 9 that I can put here. Likewise, only 8 that I can put here, and likewise, only 7 that I can put here. So the number of ways that you can fill up this 4-slotted pin is the product of all these numbers. You know that from the fundamental counting rule. All right. But the problem doesn't ask for the number of ways, it asks for the probability. So each one of these slots with no other restrictions would have had 10 different ways to fill it up. And so I've now calculated the probability of producing a 4-digit number without any repeats in it. And by the way, I could have done that like this. I could have said the number of ways that I can pick 4 numbers out of 10. Yeah, and in which I'm going to count the sequence 1, 2, 3, 4, and the sequence 4, 3, 2, 1, the permutations of 1, 2, 3, 4. I'm going to count each of those as a different personal ID. So order matters in this case. This top is just the number of permutations when I take 10 things and I take them 4 at a time. Yeah? And this bottom says, well, there's really, you're really picking from 10 numbers 4 times. Each one of these choices is a somewhat independent choice, if you would. I got me anxious. I'm a little sorry I said that. But one reason I did that is because rather than multiply these out, I am going to turn the calculator on and I'm going to go to math mode as I did before, swing over to probability, swing down to NPR, select that. I'm going to tell it that my N is 10, that my R is 4, and I'm going to have it calculate that, and that number is 5040 divided by 10 to the 4th, and that number is 0.504, which is the number we're looking for. Okay, let's go on to the third problem here. All right, let's take on this third problem, which makes use of combinations and permutations to calculate probability. Permutations and combinations, they're about counting, but probability is about counting, right? Probability, all of these probabilities are ratios, right? They're the number of outcomes in a sample space dividing into the number of outcomes in some event. The event that we're interested in this case is winning, what's the probability of winning the state lottery, where the rules say that 5 ping pong balls out of 20 are going to be collected, right? Those are the 5 winning numbers. It's on you to buy a ticket, and on that ticket to select those 5 numbers, but to select them in the order in which they were originally drawn. So let's think about that. How many different ways can those 5 ping pong balls, I hope you know what I'm talking about, how many different ways can those 5 numbers be selected out of 20? Well, so in this case, the order matters, okay, because if the numbers come up 1, 2, 3, 4, 5, you have to produce a ticket that says 1, 2, 3, 4, 5. If those same 5 numbers come up in a different number, 2, 1, 3, 4, 5, you have to produce a ticket that says 2, 1, 3, 4, 5. So when order matters, what I'm saying is the total number of possibilities here and the probability that we're calculating is the number of ways that I can take 20 numbers and I can pick out 5 at a time. Okay, 20 things, 5 at a time with permutations. And again, I chose permutations because the order of these 5 numbers matters. If it didn't, I would have taken combinations. All right, now you just have to ask yourselves, how many ways can you produce that one ticket? And is often the case in probability, there's only one way, right? If that number comes up 2, 4, 6, 8, 10, you have to have the one ticket which says 2, 4, 6, 8, 10. So there's the probability that we're looking for. Gosh, will I actually be able to do this? I think I can. I'm going to turn on the calculator, big step there. I'm going to go to math. I'm going to slide across the top menu to probability. I'm going to look down at item 2, NPR. I'm going to select that. It says tell me the N, tell me the R. The N is 20. Yeah. And now I slide over to what the R is. It's 5. I ask it to compute 20, 10, 5, and it gives me a number which I happen to recognize. It gives me 1 all over 1, 8, 6, 0, 4, 8, 0. Yep, and that's the answer to the problem. Okay. Thanks very much. Let's call it good.